using a concept called delegated proof of stake. It was it's created I think in 2013 by the same creator of, or the CTO of EOS today. And delegated proof of stake is kind of in a different direction from regular proof of stake in the fact that you give the power to a few entities called block producers. We have a few block producers here, but those 21 block producers that are on the EOS platform will sign the transactions and ensure the stability on the blockchain of everything that happens in smart contracts. And the way these block producers do things is by being voted into the system by EOS token holders. So, which has its positives and negatives, and I'll dig more into them later on. So what does that mean from a development perspective? So I'll just jump into scalability, which because of the nature of the governance system and the nature of how the blockchain works, Ethereum, for instance, because it's the current proof of work, it does not allow for faster number of transactions. You still have to solve a difficult problem, and that will take time. But they were able to at least reduce it to something as number of transactions can happen in, there's like a 15 transactions per second maximum at any point in time, and that it includes every single application on the platform. But at the same time, the transactions take a few amount of, it can take up to like a minute or based on the network congestion for transactions to be verified and signed and move to the next one. And that is basically just because of the fact that it's a kind of a proof of work system. So also the two other problems I see with transactional systems is that now that you're running your platform at any point in time, based on the bandwidth of the network, based on the congestion of the network, how many people are using it, the gas or the cost of a transaction might vary with time. So you might want to take that into consideration. Should you do all the transactions equally at any point in time and then the prices go like flat out after some time? Or should you like group some transactions and only run them when the network is cheaper to run things on? So those are things to keep in mind. But at the same time, the congestion might actually slow down your application. If you're doing a lot of things on the UI that is waiting for blockchain transaction to be confirmed, you might have an interesting or slow UI in that process. So it's another thing to keep in mind. So on the other hand, let's take a look at the EOS. The fact that it's a delegated proof of stake allows it to sign transactions a lot faster. So theoretically, it says it can allow up to 1,000 transactions per second on launch, though that's yet to be seen, I think. It's been tested to something like around 500 or plus. But at the same time, it can scale in the future with more machines that are actually working, better machines, bigger number of machines, and that will allow it to scale to millions of transactions, which is the scale needed to run something as big as like a social network or a payment backend for all the web. So the way this transaction works, though, in EOS is the fact that the app developer had already bought some power or CPU or RAM or whatnot. They basically had bandwidth in the EOS network in order to run all the transactions for you. And as a consequence of that, all the transactions that are happening in your application are free of cost for the users themselves. So the user does not have to pay in order to do a transaction, like an action that causes a transaction on the blockchain, which is pretty cool, because now you can, as a developer, you can go back and calculate how much you need to spend in this month or how much your growth is, and then stake those, buy some RAM. We'll go into RAM in more details later on, and then be able to develop, be able to like use the platform without like downtime. Because at this point in time, once you stake, once the app developer stake their EOS or RAM, you have access to this bandwidth, and the transaction is going through regardless. So that's scalability. On number 3 is the developing complexity, which is also important. So Ethereum smart contracts are written in a programming language called Solidity, which is which is transactional programming language. It's pretty much based on JavaScript and Node. So if you're familiar with that, you'll get the taste to how to build it very quickly. I was able to write my first smart contract within a couple of days, which is a simple time to like onboard on it. The main problem I found last year, at least, is that there's a lot of updates that are happening for both the compiler and this language itself, and you need to keep on up to date with it all the time. It's in a better state right now than what it was last year, though. The other problem is once you launch your smart contract on Ethereum and you realize, oh, there's a bug, I need to update it. It's a little bit more complex to do so because you need to make sure that's why a lot of people are spending a lot of money on auditing contracts for vulnerabilities, for bugs, and to make sure that they're doing the right thing. And with Ethereum, they need to make sure to do that before launching, because changes to the platform will be very, very difficult. And let's just look at the other side of the equation over there. So EOS is written in C++, which is basically anyone with a computer science degree has at least knowledge of either C++ or Java. And the only problem is it's not like the actual C++ that you see, like you used to develop anything. It has some limitations. Like one big one, in my opinion, is the fact that they don't have support for Boost libraries, which is one of the big C++ libraries. But at the same time, on a good side, you don't have to worry much about memory management, which is a big thing in C++, because if you do something in a transactional way, you put everything and then you forget about it. You start and we don't have to worry about like segmentation fault and other stuff.